Crypto value propositions for projects revolve around mining or staking rewards, creating a token for the project that may or may not have intrinsic value, or retaining fees at smart contract level. Tokens and smart contract fees add friction and increase gas costs, but there's another way. Reward developers at layer 1 level from the gas cost that the user already needs to pay. This is a sustainable idea that is planned by the Evmos team, an EVM-based Cosmos chain, and I'm currently implementing it. Ethereum has introduced EIP-1559, where the dynamic block base fee multiplied by the transaction's used gas is burned. So instead of being burned entirely, you can send some of that gas to the contract deployer. And this can amount to an acceptable and deserved revenue stream for frequently used smart contracts. This is a dApp with two contracts with the same functionality. The contract on the left has been registered in the developer program, and the contract on the right has not. Both contracts were deployed by the same address, and we can get the deployer's current balance plus the difference between his current balance and the previous balance. We are running on a local Evmos node with developer fee rewards enabled. Now let's make a transaction that will just set a variable in storage. Right now the variable is 0 on both contracts. We will use a priority fee of 1 GUI and a max fee of 4 GUI. The priority fee multiplied by the gas used for the transaction goes to the miners or validators in Evmos's case. And this is the amount of gas used, 43,724. This is the effective gas price paid, and it is the sum between the block's base fee and the priority fee for the validator. And this amount is in GUI. So we see here 1 GUI and 7 GUI. So the base block fee is 7. On a local testnet, we generally get low base fees because it decreases with each block that does not contain transactions. On Ethereum mainnet, for example, the base fee is around 100 GUI right now, which is 100 billion GUI. This base fee multiplied by gas used is what is burned by Ethereum with EIP-1559. On Evmos instead, this fee is split between the validators and developers, and of course part of it could also be burned if decided by governance. In this implementation, 50% of this amount, which is this, goes to the contract deployer. So now, if we query the deployer's balance, we should see a diff equal to this amount. And this is it. The contract deployer got the expected reward. And the value, of course, has been modified. Now let's try the second contract that has not been registered. And we will do the same transaction. We have the same gas used and the same gas price, but we should not see a change in balance. And the difference is 0. And we can try out another function that stores multiple variables. So in this case, the gas used is higher, 176,803. So the developer reward is also higher. And let's see the balance and the difference in balance, and it is the expected reward. So you have seen an example of how developer rewards work. With governance of percentages, you can change how much the developer and validator receive from this base fee-based amount, or how much of it gets burned. And the developer can select the wallet address where his funds are collected. But this feature is generalizable for any contract, and it should be of interest to Ethereum and all EVM-compatible chains. EIP-1559 burned fee will benefit developers instead of being lost. It is a fair implementation that rewards those who bring value to the chain in a frictionless way. And if Ethereum would be interested, I would love to implement this for the community. Based on this idea, I will present some personal contributions in future videos, the same type of rewards but for EVM precompiles, and a developer claim and challenge mechanism for bytecode source. The last idea is a proposal to send the rewards to the rightful deployer in case the code was stolen and deployed by an effort thief.